Hi and welcome back. In this video we're going to talk about numbers and about printing in Python. Now I hope you're all set up with REPL-IT, and what you'll have is your unique URL, your unique name here that you can share. If you encounter any problems throughout any of the videos, just share your code with me. In order to make things easier, I'd recommend you create a new session for every video. I will be doing the same thing, and I will be sharing all the code that we write throughout these videos with you on every lecture. So you can see that this lecture here has a resource attached to it, and that is the code that I have written for this lecture already prepared for you to look at the end once you've gone through the video. So let's begin. The most important thing about programming, and really one of the most basic building blocks, is the concept of a variable. You've probably seen variables in maths, and they normally mean a name for a value. You can give a value a name and then refer to that name over and over as you work with your program. For example, let's create a variable called a and give it the value 1. What we've done here is we've gotten the value that's at the right of the equal sign, and we've put it inside this box, and we've given it the name a. Whenever we talk about a, really that means 1. Similarly, we can also do b equals 2 and c equals 3 and so on. So we can create as many variables as we want, and they can have any name that we want. For example, we can have a variable called mySum, and this can be a plus b, for example. And we can have another sum, and that can be 5 plus 10, for example. So as you can see, whatever is on the right side of this equal sign is going to get calculated, and that's going to get put into the variable on the left. Here we're adding 1 plus 2, so this is going to be 3, this one's going to be 15. The names of the variables can be anything you like, except for a few reserved keywords and a few other names that you will want to avoid. We're going to go over the names that you'll want to avoid and the reserved keywords throughout the entire course. So don't worry too much about that. For now, just know you can give them any name you want, and it can contain letters, numbers, and underscores. No other symbols, and it cannot start with a number. So I'm just going to write it here as a small comment: letters, numbers, and underscores. Cannot start with a number. Okay? That's because when I share the code with you, you'll be able to then read these comments and remind yourself of what happened in the video. Okay, but this doesn't execute, it doesn't do anything for now. So we've created a few variables, and as you can see, we've given them a special name, which is mySum. This one has the name another sum, and these ones have A, B, and C. The names can be anything we want, but frequently when we create compound names, i.e. names that are made up of two words, in Python we'll place an underscore between the words, and the letters will all be lowercase. This is not a requirement. As I said, you can name your variables whatever you want, but this is just convention. This is what we normally do when programming in Python. Other programming languages have other conventions, and they name their variables in different ways. In addition, we normally have spaces between the constructs, between the operands, like here and there. And that's also a convention, and also not something that you have to do. Let's take a look at something a bit more complicated. For example, this expression here. 1 plus 3 times 4 divided by 2 minus 2. What do we think is going to be the output of this? And when I ask a question like that, obviously I know that I'm being recorded. I know that you're not listening to me live and you cannot reply. But what you can do is you can pause the video and give it a bit of thought. That way, by doing this interaction, you're going to learn a lot quicker than if it's just me blabbering on toward you. The normal maths rules apply in Python, as they do in most programming languages. So the multiplication and division are going to run first, and then the plus and minus are going to run after. And left to right is the order of preference, so this is going to run first, 3 times 4, That's going to give us 12. Then we're going to divide 12 by 2, and that's going to give us 6. 1 plus 6 is 7, minus 2 is 5. So maths operators, this variable here has the value 5 inside it. However, if we run our code, we see that nothing appears. If we want to look at the value of the maths operator's variable, we'll have to print it out. And that's the next thing we're going to learn in this video. In order to print something out, we'll just type print. Notice how it turns blue because REPL knows that this is a special thing in Python. Then inside the brackets, we're going to type our maths operator's variable. Okay, so it's print, open bracket, whatever it is that we want to print, and then a closing bracket. Now when we run this again, we see that 5.0 has been printed out. Not 5, 5.0. And that's because of floating point numbers. A floating point number is just a number with a decimal point. And normally, well, of course, floating point numbers have more precision than whole numbers. For example, you can do something like 12 divided by 5, and this will be 2.4. 2.4. This is a floating point number. So you need floating point numbers if you want to have the appropriate precision when you're doing maths. And in Python, as soon as you do a division operator, Python starts treating everything as a floating point number, so that you have that full power of the precision. Okay, so we can do a float division, for example, another variable that is 12 divided by 3, and then we can print it out. And what do you think this result is going to be printed out? What do you think that's going to be? Well, hopefully you got it. The result is 4.0. Even though 12 divided by 3 is 4, because there is this division sign there, Python treats everything as floating point numbers, and the result is also a floating point number, which is 4.0. However, sometimes we want to end up with a whole number instead. We want to lose the decimal because it doesn't mean anything to us, and we want to end up with a whole number instead of a floating point number. And by the way, whole numbers are called integers as well, so I'll be using that name indistinctively. So if we want to do an integer division, all we have to do is use two of these division signs. And then when we print this out, we see that 4 gets printed out. And I know that this text is a bit small. Apologies about that. So as you can see, when we did double division sign, Python saw, okay, we want to do integer division. Let's not treat things as floating point numbers. Let's treat them as integers. However, when we do something like 12, an integer divide by 5, which should be 2.4, what do you think we're going to get? What do you think the output of this print statement will be now that we know this is going to be an integer, a whole number, and not a floating point number? The rules of rounding tell us that anything under 2.5 would get rounded down to 2, and anything over 2.5 get rounded up to 3. However, the rounding rules do not apply when we do integer division. Okay, so everything, no matter if it was 2.9, everything gets rounded down to 2, or rather, everything after the decimal point just gets lost. So something to remember with integer division. Now, 5 goes into 12 2 times, and the remainder is 2. So, getting the remainder of a division is such a popular operation in Python that Python gives us a way to get the remainder using a single command. Okay? And the way to do that is by using this modulo operator. The modulo operator gives us the remainder of performing this division. 12 divided by 5 is 2, remainder 2. So 2 remainder 2. So what this is going to do is it's going to give us the remainder 2. If we did 6 modulo 5, it would give us 1, because that's the remainder of the division 6 divided by 5, okay? If we wanted to print that out, we could do that and we would get the value 2. So why is getting the remainder of a division such a popular thing? I mean, when do you ever need the remainder of anything? Well, think about the following divisions and what the remainder is. What's the remainder of 10 divided by 2? Hopefully the answer to that was 0. 14 divided by 2, also 0. 6 divided by 2, also 0. 340 divided by 2, also 0. So the remainder of these divisions is all 0. What about something like 11 divided by 2? Well, 2 goes into 11 5 times. The remainder is 1. 27 divided by 2. 2 goes into 27 13 times. And the remainder is also 1. So the remainder for these two is 1. Similarly, for 3 divided by 2, the remainder is also 1. So the pattern here is not that random numbers have random reminders, but rather that even numbers, when divided by 2, the remainder is 0. For odd numbers, when divided by 2, the remainder is always 1. So the remainder is such a popular operation because it lets us see whether a number is odd or even. For example, given a variable 37, we can calculate the remainder by doing x modulo 2. And then we can print it out. And what do we think this remainder is going to be? Hopefully you say 1, because this is an odd number. As you can see down here, 1 gets printed out because x is indeed an odd number. And now you may ask yourself, why do we care whether a number is odd or even? Well, we're going to learn about that throughout the course. But we do care. For example, imagine that we wanted to have the number 1 with this color background, number 2 with a slightly darker background, 3 light background, 4 dark background, 5 light background, 6 dark background, alternative backgrounds. How do you think we'd do that? Well, hopefully you guessed it. For every odd number, we would give it a light background, and for every even number, we give it an odd background. We need to know whether numbers are odd or even in order to do that. And the examples are really everywhere. As soon as you start programming more seriously, you'll see that this modulo operator really comes into play more often than you'd imagine. And throughout the rest of the course, we'll look at more examples of this as well. That's it for this video. I appreciate it's been a slightly long one, but we've learned a bunch of things about the most important building block on Python, which is the variable, and about printing, which is also essential. We've also looked at how to write some comments and things that won't run, and that's either this way with the 3 double quote symbols at the start and 3 at the end, or by using the hash symbol. Anything after the hash is a comment and also won't run. It's just there for you to look at, not for the computer to look at. Okay, so that's everything for this video. Hopefully you enjoyed it, and I'll see you in the very next one.